While there are rules for finding the derivative of a function, the derivative can be found using first principles, and it gives a good insight into how derivatives work. So if we take any point on a curve, it has the coordinates x, f of x. Okay, assuming that this is a graph of y equals f of x. If we then move along the curve a distance of h, an arbitrary variable, then our x-coordinate is now x plus h, and our y-coordinate has gone from f of x to f of x plus h. From that, we can find the gradient of a line joining the 2 points on that curve. The idea is that as this point approaches f of x, or the original point, then this distance h approaches 0. So if we talk about the gradient of this curve, it would be equal to y2 minus y1 over x2 minus x1. This simplifies to give us that. And what we want to do is look at the gradient as it approaches, as h approaches 0. And so we are looking at the limit as h approaches 0. And this is the formula for the derivative if we want to do it from first principles. So when answering these sorts of questions, obviously the rule is very straightforward. We multiply by the power and subtract 1 from the power. But if we want to show this using first principles, and this idea that the gradient of the second line approaching a distance of h equals 0 will approach the gradient of the tangent at that point, then we need to use the formula. So if f of x is x cubed, then f of x plus h would be that. And if I expand that using binomial expansion, I get that. So substituting in, the derivative is the limit as h approaches 0 of f of x plus h minus f of x, all over h. Remember, this is essentially rise over run, as the distance between the points approaches 0. And we can simplify that numerator, and we can substitute in 0. However, there's a problem. If we substitute in 0, we end up dividing by 0, which of course cannot be done. However, this expression can be simplified. Now we can substitute in 0, which of course is 3x squared.